You're about to watch the sky blink. October 2025, if an object outran the star field above Mars and the cameras caught it, then didn't. What story fills the frames that never made it home? If a green flash appeared for 3 seconds at U0003 UTC and half the people who stacked the images swear it's chemistry, while the other half call it a ghost of the sensor, what do you trust more, the pixels, the process, or the silence? If 3 orbiters were cued for a once-in-a-lifetime flyby and then went quiet, no raw frames, no quick look, do you chalk that up to careful calibration? Or a data set so weird that even professionals don't want to guess out loud? If an interstellar visitor refuses to act like a comet, if jets point the wrong way, if nickel shouts while iron whispers, if water sits out the dance while carbon dioxide steals the show, then what exactly just brushed past Mars? Tonight, we're not chasing folklore. We're walking through receipts, timestamps, plate scales, star catalogs, ephemerides. We're going to lay the tracking dots over the sky and ask a simple question with dangerous answers. What outran the stars over Mars? And why did the images go missing when the world was watching? October 2025. The red planet's night side is quiet, thin air rattling the rover's mast in a whisper. Perseverance isn't built to do astrophysics, not really, but it does what every curious machine does when night falls. It looks up. The rover Mastcam-Z and the Navcams rake the sky in short exposures, mostly to keep calibration honest. On one run, the stars drift as they should, tiny knives of light, steady and indifferent. And then a line appears, razor straight, no wobble, crossing the fixed constellation scaffolding at a blistering apparent speed, 60 kilometers per second. That number is a knife. Too fast for anything bound to Mars. Too consistent to be a cosmic ray's drunk scribble across a detector. Too clean to be a satellite's confused flare. 60 kilometers per second is the speed of a visitor, not a tourist from the asteroid belt, but a traveler from the dark between stars. And this month, the sky has a candidate. 3I Atlas, the third confirmed interstellar object to pay our system a brief, cold visit. Scheduled Mars orbiters go quiet. Downlink windows slide past with housekeeping, with thermal notes, with the soft throb of normal operations, but no raw images of the flyby. Cassis on the Trace Gas Orbiter, HiRISE on Mars Reconnaissance Orbiter, HRSC on Mars Express, names that usually spill a trickle of uncalibrated frames to the public archives. Don't. Teams post perfunctory updates, observing sequences executed, calibrations in progress, quality checks pending. It's all rational, all routine, except for the part where the rest of us are holding our breath, counting the days, and reading the same 4 sentences over and over. The first spark does not come from a press room. It comes from a living room, October 2nd. Stephen Burns, methodical, dry-humored, respected in the amateur community not because he's loud, but because he's careful, pushes a 9-minute time-lapse stitched from Perseverance raw frames. He anchors every still to a catalog of background stars, calibrates plate scale with known separations, and walks through his timestamps like a forensic accountant. Frame by frame, the streak holds its course against the star grid, its motion linear, its brightness steady. He posts the stack, the code, the catalog references, the hashes. Please try to break this, he writes. I would love to be wrong. Tens of thousands download the bundle. The internet does what it does best. Forks, replicates, argues. A handful of pipelines reproduce the track. One group, leaning hard on median clipping and outlier rejection, claims they see not just the primary streak but a fainter echo in the October 3rd sequence. Maybe a fragment, maybe a second traveler. Others, running more conservative stacks, see nothing but noise and accuse the first group of summoning phantoms with aggressive thresholds. At 3 seconds past midnight UTC in one stack, a green spike kisses the frame. A few pixels, a breath, and the comment threads explode. Swan bands? Someone asks, the chemist sliding in with diagrams. Or you just discovered the tragic love story of cosmic rays and saturation, congrats. A skeptic replies. The debate fractures into color channels and bandpasses. The green looks great in processed RGB. It looks less convincing in separate, unbalanced channels. People ask for FITS headers for telemetry, for anything that nails the pixel to the moment in the rover's buffer. We can't tell chemistry from math without calibration, a spectroscopist says. Show me the flat fields. Show me the dark frames. Show me the raw. Nobody has them. Not yet. The big eyes in Mars orbit were primed for this window. HiRISE can tilt and scan with terrifying precision, but it was designed to count boulders, not chase a speck at 3/4 of an AU. Its best resolution at interplanetary distance, dozens of kilometers per pixel. CAS is color-savvy and nimble, can run sequences in multiple bands. HRSC can sweep wide, stereo for structure, multispectral for clues. None of them are perfect instruments for a target this faint, this fast, this far. All of them together could still tell a story. The planning was a ballet of ephemerides. JPL horizons updated daily, sometimes twice daily, as observations on approach shaved uncertainty cones into slivers. Operations teams cued slews off their comfortable nadir pointings, reprogrammed exposure times to balance smearing against signal, and fought the clock. Deep space imaging has no live joystick. You aim where the math says the thing will be, you shoot, and you pray the sky conspired with your equations. Then the campaign runs, and then nothing. No raw dumps, no quick-look JPEGs to tide us over, just silence wrapped in professional understatement. We're calibrating. We're verifying. We will release when ready. Inside the labs, the problem is uglier than the updates admit. Cosmic ray rejection tuned for slow terrain turns out to be a menace for a streaking point source. Flat fields built for Mars landscapes don't fully translate to deep sky gradients. Radiometric correction tables make assumptions about temperature and read out cadence that break under unusual slews. A human being at a workstation has to decide if a linear echo is a faint fragment or a hot column dying slowly with every read. Stack too aggressively and you erase the thing you came to see. Stack too gently and you bless noise with a certificate of reality. The lead on one team describes it in a late-night message to a colleague. This is a minefield. Every choice has a twin that proves the opposite. It would be easier if 3i Atlas behaved like the comets we grew up on. It doesn't. Early whispers from spectroscopy, always caveat-heavy, always subject to being overturned by the next calibration, suggest a volatile mix where carbon dioxide roars and water barely clears its throat. The classic green glow from dicarbon, the swan bands we teach undergrads to spot at 516 and 563 m, is weak or missing in the professional data, but the amateur stacks keep teasing green. Nickel emission spikes where iron should dominate. Dust dynamics refuse the friendly fantail and instead present a forward-punching plume, an anti-tail brightening into the oncoming vector. If you model that jet with the usual grains in charge and light pressure, you spin the nucleus into scrap. If you make the nucleus big and dense enough to survive the torque, you make it too heavy to be pushed off its gravitational arc by outgassing. And when tracking teams do the thing they do, watch for tiny non-gravitational accelerations that betray jets, they find nothing, a path that hugs the prediction like it's on rails. The checklists pile up on whiteboards. Chemistry that doesn't read like a cookbook comet. Jets that shove the wrong way. A mass budget that looks like an asteroid while the light says coma. No measurable thrust from activity. It is a stack of and yets, a tower of unless. We are not alone in our curiosity. Radio astronomers, allergic to hype but drunk on good coordinates, book telescope time in the pre-dawn windows before solar interference clamps down. A handful go bold and point at the hydrogen line, 1420 MHz, the narrow band that SETI has loved for decades. It's a long shot, a near zero, but one group can't resist adding a twist. They run the trajectory backward with Monte Carlo swarms through position uncertainty, lay that spaghetti over the sky map of radio history, and find a dangerous coincidence, the 1977 wow. Signal region, that maddening 72-second spike in precisely the hydrogen line. The overlap probability, after error bars and honest hand-waving, is well under 1%, which is another way of saying it could easily be a dice trick. But for a certain kind of scientist, non-zero plus 1420 MHz is catnip. The observing proposals go in, sober in their language, wild at heart. October 29th, the show goes dark. 3i Atlas slips behind the sun from both Earth and Mars. Safety protocols, glare limits, solar interference, pick your reason. The net result is the same. 5 weeks of blindness, a natural intermission. Telescopes breathe. Data teams grind through backlogs. Forums cool. Flare, cool again. The calendar slouches toward December. Patience is not our best trait, so we build a ladder to climb while we wait. At the base rung, we staple repeatability. If the streak in Perseverance's sky is real, it should show up in other stacks with the same timing, the same motion against background stars, the same brightness within error. Switch the pipeline and the thing should remain. Artifacts flee when you change your tools. Objects don't. Second rung, multiband confirmation. If the green flash is chemistry, it should live in more than one color channel, and the ratio should smell like molecules that know how to glow. If it's a digital ghost, it will slip when we tilt the filters. Third rung, geometry and dynamics. If there are companions, fragments, loose shards, they should pace the primary track in a way the sky can defend. Jumping separations betray stacked noise and wishful thinking. Fourth rung, behavior that punches above nature's pay grade. Deliberate motion, narrowband radio, repeatable structures that refuse thermal explanation. The rung most of us never get to, the one that keeps nights and funding alive. Every claim climbs. Every rung is a receipt you can mark yes or no or not yet. Meanwhile, the professionals do the slow, boring heroics that keep science honest. They chase down unglamorous possibilities, saturated columns, interline bleed from a bright adjacent pixel, readout clocking that etches false diagonals at specific slews. They pull dark frames from similar temperatures, look for hot pixels that come and go like migratory birds, map the cosmic ray environment against solar wind forecasts, and set up dummy runs. Same pointing, same exposure, no target, just to see what the detector coughs up in the quiet. They write memos with sentences that feel like sentences only a planet can understand. We do not rule out faint anti-tail artifacts resulting from residual field flattening when the spacecraft heaters stepped. Outside the firewalls, the community hums its own music. One group publishes a reproducible notebook that takes you from raw rover frame to registered stack in 9 honest steps. Another shows that a green blip appears only when you normalize channels in a way that overweights a sparse histogram tail. A third gently points out that if you compare the claimed flash's centroid to the jitter pattern in the rover mast, you can align a worrisome echo between them. It's not a kill shot, but it's a warning. When your signal lands in the same pixel neighborhood every time the mast sneezes, you need to sweat, and yet under all that sweat, the central spine remains. The streak with the right speed, the right direction at the right hour, neatly tracing where 3i Atlas should have cut across the Martian sky. When the orbiters finally speak, they will have to do more than drop pretty pictures. They will need to pin pixels to stars and seconds, to show how the calibration choices move the needle, to underline where a streak is salvaged and where it is scorched, to flag the moments they threw away and the reasons why. They will need to publish not just the frames but the maps of their own doubt. So what exactly are we waiting to learn? Brightness first. Did 3i Atlas flare or fade as it knifed through its Mars window? And how did that light curve stack against the ephemerides we trusted? A sudden hump might mean fragmentation, gas, dust, change. A boring curve is small comfort, but it's still truth. Structure, second. HiRISE's native resolution at those distances is cruel, but a bright forward jet should smear or bias the point spread in ways that survive honest stacking. HRSC's wide swath might catch a shear, a kink, a lopsided coma that says, I am not a round thing. Cassie's, with color sequences, could arbitrate the chemistry fight if the filters cut the right bands and the SNR isn't a prank. Dynamics, third. Non-gravitational acceleration is a tiny effect but not mystical. Fit the path, subtract gravity, look for leftovers. Comets rarely sit still in that ledger. If this one does, we learn something weighty. Spectra, fourth. We want water screaming. We expect water screaming. We will accept water whispering if carbon dioxide is singing lead with permission slips. We need to know if nickel is truly outshouting iron, and whether that's a calibration gag or a mineralogical memo we haven't seen before. The green? Show it to us in photons that went through filters with names and curves, not just in processed color. Radio, fifth. The pre- and post-conjunction windows will be thin, early, low. The hydrogen line is a harsh mistress. She doesn't care about our narratives. A quiet dial tells us nothing except that the universe remains mostly polite. A narrow spike that repeats with the geometry that would earn us a century of careful heartbreak. The deeper you go into the stack of oddities, the more tempting it is to reach for the word you promised yourself you wouldn't touch. Artificial. Don't. Not yet. Not when natural models still have room to contort without snapping. Not when our pipelines could still be guilty of the oldest sin in data work, seeing our own fingerprints and calling them fossils. But do allow yourself one heresy. Hold two ideas in your head without letting either bully the other. Idea 1. 3I. Atlas is a stubborn rock dressed like a comet, dredged from a system not quite like ours, where metals cooled differently, where ices learned other songs, where jets find forward. Idea 2. In the tiny slice of parameter space where nature is least comfortable, artifacts thrive. Our job is not to choose the prettier idea. Our job is to find which one continues to survive as the receipts pile up. Let's rewind to Stefan for a moment, because amateur rigor is the secret spine of this whole story. He posts an update 3 days after the first stack. Small, quiet, the kind you miss if you skim. He found an off-by one and a timestamp when the rover dropped a buffer to write a housekeeping packet. It shifted frame alignment by a fraction of a pixel in a handful of slices. He reruns the stack with the fix. The streak is still there. The green flash is not. He does not declare victory or defeat. He writes, signal persists. Color transient does not reproduce under corrected timestamps. Recommend treating all color claims as unconfirmed until calibrated rover data available. That sentence is boring.
That sentence is a standard.
That sentence is why you can trust this process even when you can't yet trust the pixels. Far away from Reddit and cautious PDFs, in rooms with fluorescent lights and coffee that died hours ago, teams are doing the same work, with better tools and worse sleep. One of them stares at a plot where a nickel line stands over an iron line like a tall sibling at a kitchen counter. That can't be right, she mutters. She cross-checks against lamps, reruns the wavelength solution, hunts for a mislabeled filter. The nickel refuses to sit down. She sketches a scenario on a whiteboard where grains carry metal in different proportions because of a formation environment in a colder, darker birth cloud, where heavy elements rode different clumps. It's speculative. It's fragile. It's science. A testable story you invite the universe to embarrass. In another room, a dynamics analyst sets up a toy model to see how a forward jet could emerge without ripping a nucleus to shreds. He tries large, dense bodies that rotate slowly. He plays with vents that open on a timer like blinking eyes. He lets dust carry charge that interacts with solar wind in ways the undergraduate textbook never covered. He keeps a note on the corner of his screen. If you need 10 coins to explain one nickel, you're probably telling yourself a fairy tale. He deletes half his parameters and tries again. On the other side of the planet, a radio operator has his own ritual. He keeps the 1420 MHz band in a squint and refuses to center the story on it. He watches broader windows, keeps an ear for broadband burps, RFI ghosts, flickers that cycle with the earth, not the sky. He knows how rarely nature paints a narrow line. He knows how often we fool ourselves. He points anyway, because unlikely is not the same as don't look. The calendar finally coughs up December. The object reemerges low in the pre-dawn. Sky brightness fights back. Weather occupies its sovereign role as tyrant. There are nights where the telescopes see nothing but the stubborn fact of atmosphere. There are nights where a short sequence lands and a human being in a chair exhales through a smile they don't allow themselves often. Brightness, not spectacular, not dead. A curve that says massive and modestly active. Structure, an asymmetry that survived calibration. A forward bias in the smear that resists the best-case instrumental demons. Dynamics, still clean, no thrust we can swear by. Spectra. Carbon dioxide louder than water. Nickel at least not lying about being there, iron licking its wounds. The green? In professional hands it looks like the yearning of a camera, not the breath of a molecule. And the Mars orbiters? They release a tranche. Not everything. Not a data dump so huge it drowns the layperson, but a serious set with calibration notes that read like yes and arguments. Yes, we see this forward brightening in our best stacks, and here are 10 ways we tried to break it. Yes, the panels with nickel make our eyebrows nervous. And here are the lamps that say the spectrograph is not having an identity crisis. Yes, the absence of water at this distance is weird. And here is the radiative transfer model that explains how CO2 can dominate without declaring a waterless rock. No fragments leap out. No crisp companions march in loyal parallel. No radio spike repeats on nights when geometry and weather allow the attempt. Boring is data. Boring feeds models. Boring after a month of conspiracy-curious silence feels like a relief and a dare, because boring does not mean simple. Boring means we are arguing with a new kind of normal. So what then outran the stars over Mars? A body from a colder nursery than ours. forged where metals fractioned into ice in strange ratios. A surface that vents in fits, not fans, and throws dust forward when charge and wind conspire. A mass too stubborn to flinch when its own gases push. A chemistry that offends our habits but not the periodic table. A visitor that braked for no one and let Mars watch it pass without gift or apology. And what about the missing images? They were never missing. They were maturing. We don't like that answer, but we need it. We like our miracles hot and our mysteries live-streamed. Calibration is neither. It is months of people saying not yet, because they know how easily a single uncorrected pixel can start a decade of bad podcasts. They took the time. They killed their darlings. They published the darlings that survived. If you came here hungry for a word that would rewrite your religion, I failed you. If you came here to see how evidence behaves when the sky tempts us, I hope you're full. We still have a ladder. We still have rungs we haven't climbed. The post-conjunction window will close. Spring will hand us a handful of pre-dawn hours, a slant of geometry, a narrow lane where the thing that outran the stars will be bright enough and alone enough to shout its last clues. Maybe we will catch a final asymmetry that nails the jet model. Maybe a spectrum will bury the nickel rumor or crown it. Maybe the light curve will hiccup and confess a fragment. Late to the party. Maybe it will glide out of our reach and we will do the hardest. Holiest thing science allows. Learn from the unanswered and aim better next time. Before we close, one last note for anyone stacking frames in a cold room tonight. Watching noise bloom into dreams when you stare too long. Take breaks. Invert your images. Flip your assumptions. Ask your skeptics to tear you down. And when something survives all that, smile. Not because you have a miracle, because you have a result. Something outran the stars over Mars. We saw the line it drew. We argued over a color that vanished when timestamps got healthy. We watched 3 orbiters hold their breath until they were ready to speak. And when they spoke, they gave us a visitor stranger than our comets, but no less honest. We do not need the universe to be artificial to be extraordinary. We only need to listen correctly when it whispers, stay curious. Keep your receipts. And the next time the sky blinks, don't just watch, measure.